Hello guys, welcome back to our video on our gas plant simulator projects. And if you've been following up our series on LinkedIn, you know that we've done from series part 1 down to part 12, and now this is the part 13 of our series on gas plant DCS simulator. And don't forget that we are developing this simulator using Excel and VBA, just Excel and VBA, and then the programming of it. Okay, so if you're enjoying this program, just leave your comments, leave a like, and then you can repost or share this video. All right, so what we're going to be talking about in this part 13 of the video is we're going to be talking about gas composition. All right, gas composition. So what is the importance of gas composition? We're going to understand this in this video. So for our DCS simulator, this is our gas composition. All right, so this is our gas composition. Now of course I'm going to show you how this works, but then we need to first of all understand what we mean by gas composition. So if you are working as a supervisor or as a DCS or panel operator or even a field operator, you know, understanding the composition of the gas that is being refined in a plant is very, very important. All right, is key, right? One of the first things you need to understand if you are employed in a gas plant is actually the composition. That's after understanding the equipment in the plants. The most important is actually the composition, right? Because that tells you the kind of the gas you're going to be refining. And in fact, the gas composition actually determines the stability of your plant, right? Depending on how your plant is designed, understand? So if it is designed to refine a particular composition of gas, let's say if you're having a lean gas or a rich gas, and then let's say you have a methane of about 75%, and all of a sudden the methane has increased to about 90%, you know, we are going to be getting more sales gas, and it's going to, you know, affect your product, your LPG product and all the rest. So don't worry, we are going to go into this and, you know, break this down for us. So let me go to our PowerPoint. So use our PowerPoint to actually break it down for us. All right, so let's go to slideshow. Okay, so like I said, we are talking about DCS gas plant simulator. Okay, and this is part 13, and this is gas composition. All right, so your gas feed composition determines the entire behavior of your plant. Now that's what I've been trying to say. Okay, now it determines the behavior of your plant. It determines if your plant is going to be stable, depending on the parameters you've set on ground already. Okay, so if you have high C2 plus, you know that you are supposed to be having a larger cryogenic system, right? Because you are having a higher C2 plus, which includes ethane, propane, butane, because you're going to be getting a lot of LPG and all the rest. So your cryogenic system is going to be, you know, a bit bigger to accommodate this system. Now if you have high amount of sulfur, then of course, you know, if you're having a high amount of sulfur, of course you know that your amine system is going to be bigger, because you need a bigger system to actually remove these impurities, these contaminants in your gas. Okay, so the same thing with CO2, high amount of CO2, you know, high amount of condensates, you're definitely going to need bigger separators, inlet separators. Okay, you know, because you don't allow condensates to go to your compressors. Okay, so you need something to actually remove a lot of them. And then after the separators, you know, when you get to your compressors, after compressing, you still have condensate coming out, so you still need, you know, bigger separators to actually remove these condensates. Okay, and also sludge catchers, right? If the gas is coming from a far distance, definitely if we have high condensate, then we're going to have a lot of, you know, condensate, you know, coming out before it gets to let's say before your battery limit and all the rest. So you need need a lot of a bigger one to actually remove the liquid that is going to condense on the pipeline. And also for unstable feeds, if you have unstable feeds, definitely you're going to be shutting down your plants often. So, and then you're going to have what you call compressor surge, right? If you get to the compressor aspect, we're going to talk about this surge, right? Now, when there's a particular flow rate that compressors are not allowed to go below, right? So if that happens, you're going to be having a surge. So we're going to talk about that later. Then we have flare load. So like I said, if you're refining a gas that has about 65% methane, and let's say all of a sudden you start having a gas that has 90% methane, what you're going to have is a lot of sales gas will be generated, and then you need to start flaring most of them out, because your lane separator is gonna be overwhelmed with gas, so you need to start flaring most of them out. So understanding this is very key. It's very important for operators, for supervisors, for control room operators, or panel operators. It's very important. So why gas composition matters in a gas plant? Why does it matter? We've been talking about this, but let's still break it down. Now, natural gas is not just a gas. Hope you understand what this means. Natural gas is not just a gas. Now, this is because it is categorized as lean gas or rich gas. So we can just use these two terms, either rich gas or lean gas. Okay, and each type behaves differently in the gas plant. You see, this is still coming up often and often, right? So these two behave differently when you're refining. So let's say you're refining a gas that has 65% methane, and all of a sudden you have 90%. What's going to happen? What's going to happen is that we are getting a lean gas, and that lean gas is going to be giving you more of methane, more of sales gas, okay, which is not what we need to for our LPG. All right, so most of them, they are just going to go into from the top of the demethanizer, and then goes to your cryogenic system, and then you just set it out as safe gas and all the rest. Okay, so let's go to lean gas now. So lean gas is gas that has 75% to 90% methane, right? Now this kind of gas is perfect if your gas plant, if the purpose of your plant is to get GTL, right? Now an example of this kind of plant is the Escravos GTL plant, right? I'm going to talk about this Escravos plant later in this slide, okay? Now this gas plant converts lean gas, sales gas, to diesel and naphtha. Yeah, you heard that right? It's somehow, right? But then it happens. It is a process called Fischer-Tropsch process. Now what it does is it merges lighter hydrocarbons into heavier ones, enabling you to get diesel and then naphtha. So it's done at this plant, okay, and it's good for pipeline sales gas, right? So if the essence of your plant is just to compress the gas and send it out through pipelines as sales gas, lean gas is very good for you. So like I said, composition, we are looking at composition, right? You need to know so that you position your plant to be able to refine the kind of gas that is sent to you, either lean gas or rich gas. So the next is, it is easy to treat and compress. Very easy to treat because it's lean gas. So what you need to do is just remove your impurities, use the amine, use your tail contactor, you remove the impurities, the water, CO2, remove hydrogen sulfide. When that is done, you compress it and then you send it out through pipelines as sales gas. Simple. You just send it out to power plants. That is what most of our power plants use in Nigeria. Okay, so you just send it out through pipelines to power plants and other commercial uses. Okay, now it is low LPG and condensate yield, so you are not going to be getting more LPG. You are not going to be getting condensate yield. So this kind of plant, if it is, let's say 90%, you don't even need LPG, or let's say you can do LPG to just give your neighboring communities or stuff, but you are not having a lot of them, just a little amount of them. All right, so the next one is our rich gas. So when you say rich gas, it means have a lot of C2+, a lot of ethane, a lot of propane, a lot of butane, and then if you're talking about pentane, it means you're talking about having condensate, right? So This kind of gas is ideal if the purpose of your plant is to get LPG. If you have off-takers that they need a lot of LPG, then what you need is a rich gas. Okay, don't forget, if you want to just be supplying gas to power plants, okay, compression stations, then what you need is lean gas. Okay, so for rich gas, it has higher NGL, condensate and stabilizer performance. It requires more cooling and compression, more economic value from propane, butane and condensate. You know, these gases are a bit expensive, so if you can do this, you're going to be making a lot of money for your company. So in simple terms, what you want, if you want LPG, then what you need is a rich gas. Don't forget, if you want your products to be LPG, the kind of gas, the kind of feed you need is a rich gas that has a high amount of C+, right? We have higher ethane, in fact higher propane and higher butane, because for LPG it's a combination of propane and butane at a particular ratio, right? So, but then if you want GTL, diesel or naphtha, then what you need is a lean gas. Or if you just want your plant to just compress your lean gas and then send it out, you know, then what you need is lean gas. Hope you understand this. This slide is very, very important. Okay, so let's move forward. Now I just want to talk about some major gas plants and their feed composition. Just want to mention some of them so that, you know, you guys can know the kind of plants we have in Nigeria and maybe somewhere else in the world, and then the composition that this feeds, so that when you walk into a plant, you know that, okay, this plant, take for example, you walk into Oturugu gas plant, you know that this plant is refining amount of gas, kind of gas. Okay, so that is what this particular video is all about. So we have the Oredo gas plants, Ododo, Epegu and Oredo gas plant. Now this is an NPDC plant, right? All right. Now the source for this gas plant is actually gases from the Oredo fields. Okay. Now the Oredo, they have a lot of, you know, marginal fields, you know, pockets of feed here and there, EPF fields, early production facilities, and then they are all tied in and then sent to this gas plant for processing. All right. So the gases coming out from their three-phase separators, from, let's say, separator 1, separator 2, or separator 3, both the LP, the MP, and then the HP gases are tied in and then sent to this gas plant for processing. Now the gas here is very rich gas. They have a very rich gas. You know what it means when you see rich gas, right? So we have high amount of ethane, propane and butane, right? Now your products and the benefit of this kind of gas plant is that you're going to be getting LPG and NGL, right? So let me use the opportunity to just you know, show you what is happening here on the screen. Okay, so like you said, this is the gas plant. Now you see these towers you're seeing, these are your the towers for the plant. Now you see the middle one here, this one here, just follow my marker here. So this is the demethanizer, right? So this is like the first tower after your cryogenic section. The gas goes into your demethanizer. So, you know, at the top of the demethanizer we have your gas, you know, going to support your cryogenic section again, right? Then from there it goes out to your sales gas. Okay, then at the bottom we have a gas that goes to it goes to your boiler section, and then we have the reflux also. It goes to the boiler section. Yeah, we don't have a reflux for this. All right. So the second one you're seeing here is your de-ethanizer, right? So that's the de-ethanizer. Now your de-ethanizer has, at the top, it goes down to what you call reflux condenser, right? So this reflux condenser condenses and then sends it to your reflux drum. So your reflux drum now sends the gas back to the tower, where it stabilizes the top of the column, and, you know, a lot of heat exchanging, a lot of exchanging takes place inside. You know, the colder one will be coming down, exchanging heat with what is inside to stabilize the column. At the bottom, we have a cut. The heavier product are cut out from there. It goes to your boiler, and then your boiler exchange the gas from the boiler exchange it with hot oil. So the hot oil heat up the gas from the bottom of the tower. The lighter components will now go back to the tower and, you know, start following up with what is going on inside the tower. The heavier ones, you know, will be sent to your depropanizer. Okay, so this one you're seeing here. So this is your depropanizer. So at the top of your depropanizer, you see the gas comes out and then it goes to air cooler. So we have air cooler here. It goes to the air cooler. So from the air cooler, you know, heat exchanging takes place, you know, with atmospheric air, and then it goes down to a reflux drum. Reflux drum sends back to the top of the tower. As you can see the line going up here, the top of the tower. So, you know, the same thing, stabilize the column and all the rest. And at the bottom again, we have the boiler. So the boiler, the same thing with hot oil, exchanges it, and then the lighter ones will just go back up and go to the tower, and then the other ones, you know, continue our journey down to the debutanizer for extracting butane also. Now, so there what happens is the butane is also extracted, and then the same thing happens. We have a reflux drum here. We have air cooler, reflux drum, and then we have the boiler is here, and then from here the heavier ones continue down to the stabilizer column. I think the stabilizer column should be somewhere around here, somewhere around the background there. And then one important equipment we have here is the TEG contactor. So this TEG contactor is saying here, this is what removes water from your system. Okay, so we have regeneration that takes place and all the rest. So a lot that we're going to be talking about all this in this our DCS. I think I've talked about this, but then operationally we're still going to talk about it. All right, so that is that about the Oredo gas plant. So let's go to the next one. Let's go to the next one, which is the Urban gas plant. So this gas plant is also owned by MPDC and Seplat, and is situated in Edo State. Okay, now the Urban gas plant is the source of the gases to this Urban gas plant is from the Urban and the Okpe fields. Now, so all these fields, you know, gather the gases and then send to this gas plant for refining. It has rich gas, so we have more of C2 plus, propane, butane, and you're going to be having strong LPG and condensate as our output. So let's go to the next one. So we have the Ano gas plant. If you've not heard of Ano, this gas plant is actually in Imo State in Nigeria. Okay, the Ano gas plant is at Asa North or Aji South. And then the gas plant receives wet gas from the Ano fields. They are onshore platforms, and then they are developed by Shell, Seplat, and then the JV consortium. Okay, so the composition is wet gas. They are rich in C2 plus and then condensate fractions. Now, why is this gas plant very important? It supplies domestic power, industrial users, and provides liquids, LPG and condensate for commercial sales. The quantity refined for this gas plant is about, let's say, 600 to 850 million standard cubic feet per day. So another gas plant here is the Uturugu gas plant, SPDC, and then the energy hub. Right now, the feed from this gas is from your okay. So the feed from this gas plant is from the Uturugu gas fields, nearby energy clusters, cluster west around Ugeli East, Ugeli West, and other fields routed to the Uturugu hub. Okay, the composition is lean methane. You see why I brought these gas plants as part of the example. Now the rest we've been talking about, they are rich methane. Now this is lean methane. Now we have this in Nigeria. Okay, so what this plant is doing is to to work on to process lean methane that has about 85 to 90.2% methane, right? So this gas plant is one of the most simplest gas plants you can find in Nigeria. Why? Based on size anyway. We have smaller gas plants. We have gas plants that are about 2 million standard cubic feet, very small. Those ones are anyway. But for these gas plants, what it will do is simple. It takes the lean gas, removes all the impurities, water, CO2, the hydrogen sulfide, and then compress it, send it out through pipeline to Escravos gas plants. Did I say gas plant? No, sorry. To power plants, to compression stations, and other commercial facilities. So when you talk about gas plants, you're talking about the Egbin gas plant, the Geregu, Omotosho, Olorunshogbo, and other domestic marketers. Okay, so the capacity of this plant is about 150 to about 600 in between million standard cubic feet per day for the energy 1 and energy 2 anyway. Now the product is purely sales gas. So in this plant there is no methane condensation, no cryogenic section, no LNG, no NGL recovery. Okay, just sales gas, compress and send it out through pipelines. So it's very simple. Alright, so we have the Escravos. So like I said, Escravos, they take their gas from Uturugu gas plants and other sources like Escravos and Sonam fields. Okay, so these are dry wells that have lean methane rich gas. Okay, so why is this plant very important? Now this plant is very strategic, right? Now you can't afford to be flaying out all your lean gases, right? Because the consumption rate in Nigeria cannot accommodate the amount of lean gas being obtained from our gas wells. We have massive gas wells massive gas reserve in Nigeria. Okay, so this facility actually helps to convert these lean gases to what you call the GTL, diesel, or naphtha, right? Yes. Now what it does is it uses a process called the Fischer-Tropsch technology to convert the gas to syngas, then from syngas to by bonding smaller hydrocarbons into longer chains, and then we get diesel and then naphtha. So that's our product, diesel and naphtha for this gas. Now don't forget, beside this gas plant, Escravos GTL gas plant, we have CNL Escravos gas plant also, and we have phase 1, phase 2, phase 3, EGP1, EGP2, and EGP3. So for these gas plants, they actually are getting other products. Okay, so we have the overall part of them all in Nigeria is LNG, Bonny Island, right? So that is the biggest. Now for Bonny Island, we have train 1, we have train 2, we have train 3, train 4, train 5, train 6, and train 7 is currently being built. And train 7 is about 80% completion, right? Each of these trains is about 400 million standard cubic feet per day. You can imagine, very mighty. Now the combination of all these 7 is going to give you about 3.5 billion cubic feet per day. Exactly. So it's a massive set of gas plants, and it's strategic in Nigeria, right? So the composition is rich wet gas with a lot of C2, C3, and C4. So what you get is LNG and NGL. Alright, so let's talk about the gas sources, right? So we've talked about the gas composition and some few gas plants in Nigeria, and we can also mention some of them in other parts of the world. In Qatar we have Ras Laffan, and it's a 10 10 billion standard cubic feet gas plants per day. And we have in US, I think there's one they call the Permian. So the Permian refines about 500 to 1,000 million standard cubic feet per day. We have in Saudi Arabia, Hawiyah. So Hawiyah is 2.4 billion cubic feet per day, and we equally have in Norway, I think Casto. So Casto is about 2.5 billion standard cubic feet per day. So that's other ones we have for Gazprom. A lot of them scattered all around the world, mighty, massive. So we talked about gas sources. Now, when you have a gas plant, right, you don't depend on one source, one pipeline giving you gas, okay? Even if it's giving you 100 standard cubic feet per day, 100 million standard cubic feet per day, you don't depend on one pipeline. Because what peradventure, they are doing maintenance. Peradventure, there is vandalism, and then the line is cut off for months. Your gas plant is going to be dormant. It's going to shut it down and be dormant for a lot of time. So what you do is you try to get a lot of clusters, tie into your plant, right? You get from different sources. If you have a lot of gas wells, onshore gas wells around you, or maybe offshore, you can tie in all of them, to your LP separators, HP separators, and then your MP separators. So your inlet separators. So you tie them in, so that when one of the pipeline is not functioning, you can depend on the other one. You can just reduce your capacity. So let's say if you are refining about 200 million cubic feet per day, what you can do is you reduce it to about 100, and then you can shut down some of your compressors, and then you can do that. But you don't depend on only one source of income. So we have associated gases and non-associated gases, and also we have some gathering facilities, right? So for those smaller gas plants, they can just go to all these facilities that flay their gases. They flay a lot of gases. They can partner with them, and then build a small modular gas plant very close to them. I think there is a company I know of, I've worked with, that actually does this. They have the resources. So if you have a gas, they can just come to your place, erect a modular plant, and then they start doing that. So from about, let's say 2 million scof, 2 million scof to 5 million, 10 million scof per day. You can get it from gas gathering plants. There's one in Bayelsa, one gathering facility in Bayelsa at a shell at what's the name of this place? Obuna. Obuna in Bayelsa State. It's a gas gathering facility there. So a modular plant like that can be set up around there. And then we have a lot of them across the country. And then we have associated gases, where gas is associated with oil and other gases, and separated with at the three-phase separator. At the top, gases go out, HP gas, LP gas, and all the rest. And then we also have the non-associated gases, which are our dry wells, right? So that's our source. Now, conclusively, we need to know, as an operator or as a supervisor or as a panel operator, you need to know that when starting a gas plant, or when you want to simulate a plant, just like we're doing, we are simulating a plant, but in a real sense, when you want to start up a plant, you need to ask yourself, if your gas is methane and it has about 10% to 90%, you need to know that you are expecting low LPG. Understand what I'm saying again? If the gas composition that you want to refine or you want to process is having 80% to 90% methane, you know that gas is a lean gas, and the product you're going to be getting is low LPG, and you're going to be having high export gas or sales gas. All right. Now, if the gas you want to process has higher propane and butane values from 10% to 20%, you know that you're expecting to be getting high LPG output. Okay, and then if you are having a percentage of about 3 to 6% of your pentane, expect that you're going to be getting a lot of condensates. Right now, if you have this at the back of your mind as an operator, whenever you see a lab results of the composition of gas that you want to refine, it will click to your mind that, okay, this is what is going to happen. We are going to do this. We are going to do this. and economically, right, you can advise the management that okay, the gas we're getting is having a lot of percentage of methane, so it's the lean gas, so we are not expecting a lot of LPG. So this is going to help you in economics to be able to calculate your revenue at the end of the day. Okay, so gas plants don't run on only pressure and temperature. All right, now we know that the operating parameters that we tweak that are very important that we use to run the plants are actually pressure, flow rates, and then temperature. In fact, for gas plant, pressure is very important, very important. Pressure is number one, right? So but then composition should be added as a parameter. The composition is very important because you need to ask yourself, what is the composition? Now that will even give you an idea of the pressure to tweak, right? So if you understand your feed composition, you understand your plant performance. As simple as that, right? Like I said, the composition determines your performance, the behavior of the plant. If it is lean, if it is rich gas, it determines the behavior of the plant, right? So it's going to help you understand your product yield and understand how to calculate your economics. All right, so it's very important. So let's go back to our DCS simulator, right? So this is our DCS simulator. Like I said, this is made with Excel. Now, as you can see, talking about the gas sources, right? So we have about 1, 2, 3, 4, 5, 6. So we have about 5 sources of gas coming to our plants. Now some of them might be low supply, some of them are low supply, some they are like 4 million standard cubic feet per day, some are like 20 something million standard cubic feet, some are 19, some are more than 20, some are 25. You understand? Now if you add all of them together, you might be having around 100 to 140 to about 200 million standard cubic feet per day. But what I'm trying to emphasize is that you should have a lot of source of gas to your facility, so that when one of them is shut down, you can be refining from the other one. And also, as you can see, one of the source here is my EFS test separator. Now what this means is that this is going to be intermittent, right? So whenever we drill a new well, a new let's say early production facility well, and then want to test it, the gas we obtain from this testing is sent to our gas plant for processing, right? So this is also part of it. Now after the testing, this guy is closed down, and then we continue with the rest, right? And then you can see we have other ones. We have the LP gas, we have the MP gas, we have the EFS, EPF, we have the inlet gas. So all of them, you see this one is giving us about 25 million standard cubic feet. This one is giving us about 7. This one is giving us about 19. This one is giving us about 22. This one is giving us 0. So I will need to, don't worry, I will simulate it for you to see. Now this one is giving us about 0.1. Okay, so and the total here is 74 million standard cubic feet per day. Okay, so that's that. Now let's look at the composition now. Now looking at the composition, you find out that my LP gas is having a methane composition of about 65 mole percent, right? So this is a lean gas or a rich gas? First of all, okay, I think you get it correctly. It's a rich gas, right? Because as you can see, the percentage is less than 75%. Like I said, above 75% is going to be your lean gas or thereabouts, above 25% to 90% or thereabouts. Now this is 65, so definitely you can categorize this as your rich gas. Now the second one is a lean gas, third one is a lean gas, fourth one, fifth one, sixth one, these are all rich gas. Now we are working on it, right? I can just decide to change all of them. So this is 75, I can just decide to change it to 60, and then I work on this other one. I give this about let's make it about 15, and then I give this about 6, so 95, so I give this about 11, So this is 100. Now this now is a wish gas, right? So I can change it like that. Now you know, this is a simulator, so we can play around with the parameters. If we want to refine a lean gas, we play around with the parameters, change it to lean gas composition, and then we'll refine it and see the output. And also if we want to refine for rich gas, we can also tweak it. So that is that. Now you see we have water. The percentage of water here is about 0.3%. We can tweak it. Like this other one is 0.2%. This one is 0.7%. We can tweak it to know the kind of you know, water content we have. And then for our pentane, you see pentane is 1% here, and here also we have 1%. So the amount of condensate is low here. So we can tweak it, increase the amount of the pentane, so that we can, you know, have a lot of condensate. So composition is very, very important. Okay, so let me show you. This is our LP. So I'll just put this on so that you see. Okay, so as you can see, the amount of gas entering the inlet separator is increasing, right? It's increasing. We can just put this on now. Sorry, we are not doing this for now. I'm gonna come to this, but I'll put it off. I just want to show you that this is increasing, right? So we go to the composition, we see it here is increasing, and then we can go to the MP. MP is also 0 here, so the MP gas inlet is 0, so I can increase that too. And then we go back to the composition. You see it's going up, right? So during production, during startup, right, you communicate with the supplier and you tell them, okay, I need gas. You can open up your valve and then give us gas, and I need it to be at so pressure, right? And also your field operators at your battery limits, definitely you have control. You have you know, pressure gauges that you use to check the pressure, so you know, control it. But before then, definitely, you know, you need to take a sample of the gas and then you test it at the lab to know the composition of what you have, right? So this is about gas composition. I hope the video is not too long, and I hope you understand about gas composition is very, very important. Okay, so if you like the video, give a thumb up, repost, share this video, and then follow up with this content, and let's try to understand the gas processing. So for those for the field operators, or for those graduates that just want to go into gas processing, your education, your first degree cannot give you the experience you need to get into the gas processing plant. All right, so courses like this, series like this can actually give you the broad knowledge that you need, right? So thank you. I will see you in the part 14 of our series. Thank you very much for watching.